Hello dear students, Savita Pruthi this side. In our last lecture, we discussed about chemical shift, and today we'll be talking about units of chemical shift. Now we know that chemical shift is the shift in position of NMR signals with respect to a reference compound, and the reference compound that we use is TMS. You know, TMS means tetramethyl silane. And this difference in the position is measured in terms of difference of frequency. So what we expect is that units of chemical shift should be in hertz. So here I have written that chemical shift, that is the shift in position of NMR signals, needs to be expressed in hertz as the difference of frequency of absorption of a particular proton and that of the protons of TMS. But now we know that frequency and external magnetic field, they are related to each other by formula nu is equal to gamma h naught upon 2 pi. Means if frequency of the oscillator changes, parallel frequency, the magnetic field will also change. That is, frequency depends on external magnetic field. Now I take a particular example. Say we have acetone. Acetone has these 6 protons and all the 6 protons are equivalent. So they absorb at one position, they give one signal. And that appears 126 Hz downfield from TMS. And when the frequency of the spectrometer is 60 megahertz. I have shown over here. See, this is the position of TMS signal, which is an intense signal, and that is assigned value 0. With respect to TMS, the signal of acetone that is appearing here, this is for 6 proton, and you can see the intensity difference also of 12 protons and 6 protons. This appears 126 Hz downfield. TMS is having most shielded protons. All the 12 protons of TMS are highly shielded, and with respect to TMS, all other organic compounds have protons which are de-shielded. तो TMS के कंपैरिजन में हर प्रोटॉन डी-शील्डेड होगा. जितना इसके नज़दीक होगा वो कम डी-शील्डेड है, जितना दूर होता जाएगा वो ज़्यादा डी-शील्डेड होता चला जाएगा. So this position is called upfield position and de-shielded position is called downfield position. Okay. So now, where is the problem then? Why I am discussing all this? That I gave sample of acetone to say different sets of students, different groups of students. एक ग्रुप को मैंने सैम्पल दिया. आई डिडंट टेल कि ये एसीटोन है, बट आई नो दैट. तो हमने वो कंपाउंड दिया और कहा कि पता लगाओ कि एसीटोन का सिग्नल कहाँ एब्जॉर्ब करता है. दे वेंट टू द लैब हैविंग द स्पेक्ट्रोमीटर एंड सेड दैट द गिवन कंपाउंड एब्जॉर्ब्स 126 Hz downfield. Okay, I gave the same sample to the other students. They said it appears at 210 Hz downfield. And the third group of students said कि the same compound that absorbs now 252 Hz downfield. So what's the problem? Are the students wrong or there is something else? None of the group was wrong. जिन्होंने कहा 126 Hz डाउनफील्ड आता है वो भी ठीक थे. जिन्होंने कहा 210 Hz आता है they were also right. और जिन्होंने कहा 252 Hz आता है they were also right. So now where the problem arises now? Now the problem is the frequency of the oscillator. Oscillator frequency means कि जिन्होंने कहा कि 126 हर्ट्ज डाउनफील्ड आया है, एक्चुअली उनका स्पेक्ट्रोमीटर की जो ऑसिलेटर फ्रीक्वेंसी थी वो 60 मेगाहर्ट्ज थी. जिन्होंने कहा 210 हर्ट्ज आया है, they had run the spectrum on the spectrometer with 100 megahertz frequency, और जिन्होंने कहा कि 252 हर्ट्ज आया है उन्होंने क्या फ्रीक्वेंसी यूज़ की है, 120 मेगाहर्ट्ज यूज़ किया. सो फ्रीक्वेंसी ऑफ द स्पेक्ट्रोमीटर मैटर्स. अगर हम इस कन्फ्यूजन को हटाना चाहते हैं कि दुनिया के किसी भी हिस्से में अगर किसी कंपाउंड का स्पेक्ट्रम रन किया जाता है तो ऐसा कन्फ्यूजन तो नहीं होना चाहिए. एवरीवेयर द वैल्यू शुड कम आउट टू बी द सेम. सो द सॉल्यूशन वाज टू डिवाइड द फ्रीक्वेंसी डिफरेंस with the frequency of the oscillator. See, here I have written that 126 in the last line, 126 divided by 60 into 10 raised to power 6 is equal to, that is 210 divided by 100 into 10 raised to power 6, and here 252 divided by 120 into 10 raised to power 6. Every time when you will divide, the value will come out to be 2.1 into 10 raised to power minus 6. Now in order to avoid this confusion, not confusion, every time we'll have to write 10 raised to power minus 6 with every value. So we have multiplied each time with 10 raised to power 6. So now the value comes out to be 2.1 into 10 with no powers. So what that means is that now the units of chemical shift वो क्या हो जाएंगे, units of chemical shift will be parts per million, ppm. ppm means कि जो हमने लास्ट में सबको 10 raised to power 6 से मल्टीप्लाई किया है, 10 raised to power 6 मीन्स मिलियन, तो 8 मिलियन पार्ट्स में कितने पार्ट्स से शिफ्ट हो रही है, that is the units of chemical shift. So instead of measuring chemical shift in frequency units in hertz or in the magnetic field units means in Gauss, we have measured the chemical shift in ppm by dividing the change of shift of the proton signal with the frequency of the spectrometer. And now तुम दुनिया के किसी भी हिस्से में एसीटोन का स्पेक्ट्रम रन करोगे तो तुम देखोगे कि इट अपीयर्स एट 2.1 ppm वैल्यू. ओके.